What's up, everyone? John Ray from the Techno Buffalo here. I want to give you guys the chance to win what I think is going to be.
Shut up. Come on, man. Really? Come on. Come on now. Come on now. So many commercials. Come on, man. Give me some music. So I can continue with the layout. Alright, I gotta do some changes here. We need to reinforce those copper layers. Sorry about that. Copper layers. We have almost everything figured out, and then I will start to do the tweaking on the PCB. So I think, okay, let's do the test. The test just to make sure that everything is correct. We had the yes. I need to change this. I just have the idea right now. What happened with the music? Come on, man. Jesus. So much commercial, man. I don't want, oh, Jesus Christ. Let me listen to some sad music. I don't want my channel to be flat because I'm listening to sad. Alright, let's see this one here. I hate the commercial, man. Come on, man. Really? No commercial, please. There you go. I gotta lower the volume because I need to be able to see. Alright, so we had these connections here. Oh, I forgot. I did forget. Got a ring terminal. Oh yeah. Ring terminal. The screw is 6.32. Alright. Okay, so we got this figured out. And the connection test, I forgot to do that. Alright, so we had the AC voltage. We had two of those for the windings. So this is the first connection for the bridge rectifier. And then, okay, it's correct. And we had the other one that is actually protected by the fuse, so it's good to go. We had another one here. It's protected by the fuse. This is the connection, and the other one, so it's good to go. All right. Green 632s. Let me see. 632. Should I? Let me see if I can. 632 star. Okay, 6 star. 632. 6 star. That's the one. Is that the one? 6. All right. Let me see. All right. Let's see. Okay, we had this. Okay. This is insulated. This is a typo that is insulated. We got, okay, we got the blue one. Okay. Like a high quality one. $632s. Dang, that. All right, let's see. I think that for class AV audio amplifier power supply, the wiring is, I think, is yellow for the negative, red for the positive. I gotta make sure that I have everything figured out. Good quality. Looking for good quality connectors, or better say high quality. Like 632s. stud is the crew size 632. Okay, the DG key. Oh yeah, let me do this. Let me change this configuration right here. So I'm gonna move the fuses to the left and having this in another way. So it's going to be nothing is going to be on its way. So I already saved it. Oh, this is the master. Oh, the master is this one here. This is the master file. I forgot to do that. So this is only, we got the master file. So I need to move this to the left. Move this. I can keep this connection here. It's okay. The capacitor is fine right there. So I edit this because the screw cannot be touching this area, copper area. It's okay. I can fix that. It's okay. Build group and then move it to the right. Sorry about that. Move it to the right. Okay. I think I might need some more space for this. It's okay. I can keep. All right. I gotta do some small modifications here because we need to have the terminals to the how you call it, the outline of the PCB. So it's going. This is the outline of the PCB. So we need those terminals to be easy to place there. Okay, so I'm gonna move this over here just to be sure. Okay, I got another idea. Hold on, let me see. I think I can make another thing so I don't have to move much stuff. Material. Gotta move the copper. I think okay, there you go, there you go. There you go, 45 degree. There you go. Oh, hold on, man. Come on, man. Come on. You can do it. Alright, we got this one here. So we need to move this. So we know we need to have enough space for this, for the nuts. But we need to be aware to try to keep the nuts away from the copper area, because it's gonna have voltage, AC voltage there, so we don't want any voltage involved there. So I gotta keep thinking. The M3 screw, I think it's pretty small. M4 screw nuts. Let me see. M4 screw. M4 screw nut. Let's see. Size. Let me see. Nuts, bolts, dimension, metric, hexo. Okay, I need to see the size. Oh, that's good. We got some information here. Alright, so M4 screw, range size, thickness. And 5, we had 4.4. Oh, okay. This is what I need. I need the measurements. F. How about G? G is more important. I need G. Let's see G. It says M4 screw 7.66. So let's go with 8 millimeters, just to be sure. I think the M4 should be better for this application. M4 screw. So we got 8 millimeters. Let's go with 8, just to have enough space. 8 should be just fine. So I need to make 1 8 millimeters, just to be sure that nothing is going to be touching the copper area So we gotta put it. Oh, there you go. I see that. So we need to add more space. It's okay. I can do that. So that's 8 millimeters. So we need the enough space so the bolt, the nut. Sorry about that. The nut is not gonna be touching any area of the copper, because that it's gonna have voltage right here. So we need to be aware of that. Oh yeah, I forgot to edit the thing. It's okay. I did it on this one here, but it's okay. It's okay. I can fix it right away. It's not that difficult to do. So what I'm gonna do is easy. I'm gonna include these two here. I just gotta be sure that hey, there you go. It's simple to do. All right, so I need to build a group. All right, so because I gotta keep remind myself that I'm working with the master file. So I needed to copy this and this, build a group, and then copy. And this is the master file. So I gotta delete this one here because the standoff cannot be in contact with any copper area on the PCB. So that's really important right there. So just to avoid any short out. So that's really important. So I need to be sure that I have the grid. There you go. That's the grid. Perfect. So now I can delete it. So I can delete this here. All right, let me see. Okay, I see something else that I gotta delete. It's this one here. There you go. All right, so I'm gonna make the test. I'm gonna save it. I just gotta be sure that to explain you better what I'm doing is that we need a standoff to secure the PCB to the chassis. So we need to have some clearance distance between the standoff and the copper area. The copper area should not be touching any metal part or of the standoff. If they are made of metal, that create a problem. But if they are made of plastic, it should be no problem at all. So that's why I'm making sure that the standoff, hex standoff, is not going to be touching any area of the copper. So I need to fix this. So hold on, that's the. Oh yeah, I'm measuring the nuts. I forgot the nuts. So I'm gonna make one right quick, sort of like artistic one. Let's see. Let me see how big I need it to make. 6, 8. What about 8? Should I make 8? There you go. That's too big. Okay, 8. Oh, half. It has to be half. Okay, let me see. Hold on. Give me a second, guys. So it should be 8. Half of that. Something like this. So that's kind of like the bolt. Sorry about that. What I keep saying bolt, not. Oh Jesus Christ. So okay, so I got that. So I'm gonna make just a simple drawing, just to reference only. Let me see. Just to sort of like make the image of that particular bolt. Not. Damn it! Keep saying the same thing. Oh my god, it's okay. There you go. Let me see if I can make it smaller. Okay, I mean something like that, I think. Gotta change the grid. Okay, 0, 0. Okay, let me see. I'm glad that I use a CAD software for a while, but I mean I forgot many stuff that I used to do with the CAD software, but it's okay. No, it's not a big deal. So this is the. There you go. That's the center. So that's the bolt. Oh, God damn it! I keep thinking about bolt. It's a nut. Oh Jesus Christ! It's a nut, but again, why you keep saying bolt? Yeah, man. I think so much air conditioner that I fixed in the army got me thinking like in bolts. It's okay. So we had the nut here ready to go. So I know that I needed to give it some more space, so the edges of the nut is not gonna be touching any area of the PCB copper areas, basically. So I needed to, using this information, I can then gonna turn this into a green mask, so I can then eliminate the S1. I mean, hide the S1, sorry about that, so I can look what I'm doing. So there you go. So I needed to give it more space. Also, I should rotate it so I know the corners, it's not going to be touching any area. So let's go with 45 degree. No, it's 45. I should change it for, let's go 15. Let me see, hold on. There you go, something like that. So we know that if we rotate the nut, it's going to be touching the copper area, and we don't want that. So I gotta give it more space, even more space to this design. So this is easy to do, because when I do a layouts, I was thinking what can go wrong on the design. So anything can happen on the design if you don't think about these small details, basically small details about the design. So you gotta keep thinking, okay, what can go wrong? You know, what can go wrong on the design? So you gotta keep thinking and changing as you go, basically. So the more I do this, the more I have an idea that I gotta be aware of everything, every imperfection that might happen on the design. So it's a lot of thinking, not just throwing lines and then call it even or complete. It's not like that. It takes a lot of thinking. So I gotta give it space. As you can see, if I rotate the nuts, it's not gonna be touching any area of the PCB. So that's why I gotta give it some space for the nuts. So the nut is not gonna be touching any copper area of the PCB. So that's why I gotta keep looking, reading, searching for components. And this is basically a simple design because it's not really complicated. It's just a simple unregulated power supply. So, and it takes time. So, all right. So I gotta continue with that. Okay. All right. Let's continue here. So I gotta give it more space here. So I split the group, and I need to give it space. So the nut is not going to be touching any area, any copper area. Gotta wait for there you go. Yeah, I'm going to make sure that it's not going to be touching anything on the PCB. So, and then I can make it just sort of like artistic. That's fine right there. And this is not really needed. I mean, this shape here is not really needed. I think I can eliminate it. It's not really needed. I have the tendency to keep doing these fancy shapes. It's not really needed. I can eliminate it. It's fine. There you go. It's better like this. And then I can just keep. Okay, that's good. There you go. So now it's a lot better. So now we know that if we rotate the nut, it's not gonna be touching any area of the PCB. So that is done. Save. All right. Now I'm going to continue. So now we know the information of the M4 screw is 7.6 across. So that will be M4, so 7.6. Just round that up to 8, and that's fine. I mean, those don't need to be perfect. We only need to know that the nut is not going to be touching anything. And I think I repeated many times already. I think I repeat that many times. Also here I gotta do the same thing here. Gotta make sure that nothing is going to be touching. Okay, you can see right there, if I rotate it, that create problems right there. So we don't need the nuts going to be touching any area of the standoff, because if that happens, it's pretty bad. It's pretty. So I gotta edit this one here, basically. Let me see what can I do here. Hold on. Also, this area I gotta make sure that I gotta avoid this. We need to have more clearance, so we need more clearance. So let me see. We got 1.28. 5 millimeters. We got 5 millimeters. Okay, 5 millimeters is fine. Yeah, I forgot it. It's okay. Let me edit this one here. Let me see. It's not really necessary to give it fancy corners to the PCB. It's not really needed. Okay, let's see. It's hard to try to move this, or maybe I can create a new one. I just can create a new one. It's fine. For now, I'm gonna do this. I mean, I'm gonna make sure the nuts that holds the fuse are clear from the nut, so the nut is not gonna be messing up. It's okay. Don't worry about it, because. All right, so we got this. Oh, okay, I see now. It's okay. There you go. Okay, let me see. Oh, what? Let me see. Hold on. Oh, okay. There you go. Cool. Let me see. Make sure that everything is cool. I think to speed up things up better, I can just copy this one and place it here. So we're gonna place this nut over here to use it as reference. There you go. We got another problem here. You can see it's about touching that copper area, and that is not good. Okay, let's continue here, making modifications just to be sure that making sure that the copper it's not gonna be touching that. There you go. So now it's easy, because the only thing I gotta do is just select everything here, copy it. Let me see. I got everything. I got the bottom copper and the top copper, so it's good. It's good to go. So the only thing I gotta do is just it's fine. It's easy to do. Place it here so I don't waste time. There you go. And now I can delete this part over here. Let me see. There you go. It's fixed. Oh man, I think I gotta take a break. Oh Jesus. Woo. Oh man. Oh wow. So the clearance that I have here between this copper, it should be lower. It should have more clearance. We don't want this to be too close to this area, so I needed to move it a little bit more. Yes, I gotta do that. I do, yeah. Let's turn this into S2. Okay. Okay, there is one reason why you're looking at this. It looks like something weird, but I was thinking that I should have it in a way. Maybe I got another idea. I should have it in a way that we can use just one single bridge rectifier, or use two single bridge rectifiers. That's why I came out with this idea, because right now the design that we have, it used two bridge rectifier for the class AB audio amplifier. So this will turn into sort of like a virtual ground, because BR2 is feeding the negative of BR1 to create the ground, or basically center tap or start ground. So basically that's why it's like this. Right now, if I test both of the circuits, it's gonna look like this. So that's the ground. So I was thinking to leave those open. So if I want to choose just the bridge rectifier, I can just only one single bridge rectifier. I can choose by wire. I can make the wiring and just only one single bridge rectifier. But if we use the two bridge rectifier, the only thing you gotta do is just place these jumpers right here, and it's pretty easy to do. And that's why I place many of them, so that can carry all that current, just to be sure the current will flow good with no problem at all. So that's the idea that I have. So for now, maybe I think it's a good idea to leave it open just in case I just want to use one bridge rectifier for other circuits, other amplifiers. So that's the idea. Okay, about the standoff, to explain better, I came out with this idea of create this circle. So the only area that will be in contact with the circuit is this area, but not the standoff. So that I was able to think about it. I said, okay, I'm gonna do it like this because we don't want the standoff to be touching any area of the circuit, the voltage. So right now this one is like that. It's like that too. That you can see, only this copper area will be in contact with the circuit, but the standoff is going to be separate from all the circuit. So it's not going to be intervene. That's the right word, right? Intervene with the circuit. All right, so I gotta keep adjusting. So I know that. Well, that's a good idea. I'm gonna leave it there. The idea of the nut. I'm gonna leave it there. I think it looks cool. That's for the reference only, to make sure that you can see there is another problem here, because the nut is basically touching the copper area, so we don't want that. So we need to be sure that that's not gonna damage. Make the it might damage the circuit. So we need to know or be sure that it's not gonna happen. So that's why I'm keep looking and making improvement. Okay, I gotta split the group. Okay, one more time. Oh, there you go. We got it. All right, so that is away. So it's good to go. So the nut is not gonna be touching this copper area. So now I gotta fix the other one that is really important. So we're gonna do it right now. There you go. I think I gotta move this up here. There you go. Let me go like sort of like this distance. There you go. That's good to go. And then okay. Okay, so then I'm gonna move it here. There you go. So no matter how many times I rotate the nuts, it's not gonna be, you can see, it's good to go. Good to go. All right, save. Don't forget to save. Really important. All right, so let's wait for this. Oh, there you go. Good to go. Let's go with the other one. I think I gotta do the same thing with the diffuser for the bridge rectifier. I gotta do the same thing too. You gotta be sure that. Hey, there you go. That's another problem right here. You see? So I need to fix this. And let me see here. I think it's not really needed here because it's okay. So I know we have plenty of space. Plenty of space. Cool. Good to go. Let's see. Oh yeah, well, I think I was doing. Yeah, I did it already. See, that's good. I did it already. I forgot. This is good to go. So we need to fix this one here. Oh, let me copy this one better. Okay. See the problem right there? Okay, let me see, put it here. All right. Okay, I continue here, updating the copper area. So this one is easy. The only thing I gotta do is copy this one here and place it here and delete this area. Split the group. Okay, this one I can delete it now, and this one here. So it's good to go. So no matter how many times I gonna rotate the nut, it's not gonna be touching anything. So it's good to go. Alright, I got this one here. So the silk screen on the bottom is gonna look like this. You can see that the nut is not gonna do any damage to the PCB. Alright, cool. Good. Alright, now here we have this area to fix. We need to give it some room for the nut so it's not gonna damage anything. I think I mentioned that many times. I repeat it many times. It's okay. Alright, let's see over here. Oh, it's okay. Don't worry. Then I think it's the red one that I gotta move. No, it's not the red one. Hold on. It's the other one. This one. 45 degree. Okay, we need to fix this one here. Oh, I got a green line. Okay, I can delete this one here. It's not really needed anymore. Because I only use that for sort of like the guidance. Yeah, guidance. That's the right word, I think. A drawing also. Let me see. And then I'm gonna rotate the nut just to be sure that it's correct. Yeah, it's correct. Cool. Good to go. So, all right, and the standoff. Let me see. Hold on. Let me do the test just to be sure that. Okay, we got a positive that is going to feed the positive area, the rail. I call it a positive rail, so it's going to feed the positive voltage. So let me test it. Okay, it's good to go. We have the bleeding resistor in action, bleeding out the capacitor after you turn off the amplifier. We had this rail. Okay, it's good to go. It's not touching anything else. We had the ground. We had the negative. And you will see that it's protected by the fuses. So that's a good thing. I forgot to move the split the group, and I need to move the negative. There you go. I need to move that. Split the group. Okay. Oh, there you go. Right there. Right there. So I'm gonna move it forward to the left. There you go. So that's negative. I think I should write down B. I think it's VEE and VCC. If I'm not wrong, BEE and BCC. So I think I should write it here. BEE positive. So BEE positive. That's really important right there. I hope you two don't flag me because I'm listening to that music. Okay, there you go. VEE. I think I should make it larger. I think let's go with 3. Place a line so we know that. I think it's VEE and BCC. I'm not sure. Let me know, guys, on the comments down below. I'm not really sure. I think I forgot. Let me put this down there. So it's VEE negative down there. Then. I gotta do all the adjustment that I gotta do. I gotta make sure the the exposed copper of the PCB is not touching, is not outside of the PCB. You don't want to be touching that while you're doing test. All right, so it's not a big deal. It's really simple to accomplish. So this is VCC negative. I'm gonna type negative just as reference. There you go. So we know that that's okay. I think I gotta move it a little bit more. I'm gonna press the shift button. That's weird. Oh, I gotta do some adjustments here. Then I noticed something here weird. What the hell is going on here? Oh, okay, I see what happened. Okay, don't worry guys, don't worry, no big deal. I can do this, it's okay. I gotta remind myself that I'm working with the master file, not the other one. It's okay guys, don't worry. There you go. So that's the one, and I needed to be sure that these fuses, they are aligned with the other one. So that's another thing that I gotta make sure. All right, let's go with that. Let's see. Okay, we can use this. Trace a line just to see. Oh, I see. It's good. It's good to go. It's good to go. All right. All right, I think I gotta move the. I'm gonna move it. It's okay. I can move this to the left. 1, 2, 3, 4, 5, 6. It's a fine right there. So we got the VEE and VCC negative. So we know the polarity, just to be sure that this is sort of like a I think I gotta reinforce the copper area. I already add some. Oh, this is not the one. Golly, man, this is the one. I can do it one more time. It's okay. It's not a big deal. So that's gotta remind myself that this is the master file. All right. Now I need to do some separation here. I don't want the copper area to be outside of the PCB. Try to put it inside a little bit more, so the edges of the PCB, you're not gonna be touching those copper areas. So just to be safe, so what I wanna do is give it some extra millimeters. So I'm gonna do it right now. It's really simple. It's not that. Let's give it 3 millimeters. I think it should be fine. 3 millimeters. Just to be sure that. Okay, so we got that, and now we go. I think I'm gonna take a break, guys. I'm gonna take a break. We'll make a part 4 of this video. I will continue working on the power supply design. I think it looks great, but I think this option is essentially correct. I should have it separate, like I mentioned already, just in case I just wanted to use one bridge rectifier for other power supply design. So I think that's a good idea to leave it like that. And then I gotta fix some stuff here. This anomaly, I gotta fix it. It's okay. I can do that. It's not really difficult. All right, guys, have a good day. I will continue working with this power supply for Class AB audio amplifiers. All right, guys, have a good day.